Welcome to Module 1 of Biology. This is your instructor, Mr. Buford. You're going to learn a lot. Hey guys. All right. Welcome to Module 1. Hope you're all staying safe and doing well. As you can tell, I've lost my mind a little bit. Who hasn't? So I want to give you a quick little recap. Before we left, we were at the end of our genetics unit. We had about one more lesson and then our review and test. However, it's been 5 weeks now since school closed, and instead of us reviewing what we've covered, then getting one more class worth of content, but then not being able to take a test, I don't think that's the best use of our time. So I would rather that we move on from genetics and begin our unit on evolution. Okay. In the past, I've had a couple of concerns voiced to me about learning about evolution and students being concerned if it's going to, contradict their beliefs. I normally would have a conversation in private with students, who asked, but I'll just give you this disclaimer here. I am not here to contradict anything that you believe. Many evolutionary biologists are also religious individuals, and so if at any time you have concerns, feel free to reach out to me. But I'm simply here just to talk to you about what evolution is and how we study it. Simple as that. Okay? So let's go ahead and get into our first module of distance learning. Make sure that you have your notes outline available to you. Remember that when it comes time to do your assignments, you'll be able to refer back to your outline, so that's going to help you out there. The PowerPoint is available to you, and I've also made PDF versions. I've made a PDF fillable version of the notes and a PDF version of the PowerPoint in case you don't have the Microsoft programs on your computer. Okay, so you'll be able to get everything accomplished using this video and the resources that I've provided you. So let's go ahead and talk about Mod 1. I don't know if you're in communication with any of your peers. We may be going in a little bit of a different order than some of the other biology classes, but just know that we are going to be covering the same content. Just have, each person has their own preference, just like teachers have their own preferences, and this is how I prefer to cover this unit. So some of your peers might be doing different work than we are, and that's perfectly okay. You're not going to miss anything. You'll get to all the information, I promise. So Mod 1 begins April 15th. It ends on April 20th, which is Monday. And Monday is when your Mod 1 assignment is due. It is technically due at any time during that day. So I think It's Learning has it set to 11:59 p.m., which I hope that's not the case for you, but you have quite a bit of time there to have your assignment completed. All right, let's go ahead and dive into the information here. As we talk about evolution, just know that evolution is simply the change of organisms over time. Now, we're not talking about immediate time or even our lifetime. We're talking about generations. So your great-great-great-great-great-great-grandparent, there would be differences, possibly, that have happened over time. Because of all these changes, though, if we look at changes over even greater spans of time, say centuries or millennia, um, evolution can explain a lot of the similarities and differences between organisms that are of different species. So, for example, I've given you these photos here. This photo on the bottom is it's it's kind of like a guesstimation of what this dinosaur species looks like based off of its fossil remains. And it's considered the largest dinosaur related to today's birds. And if you look at the top image, not sure if you're familiar with that type of bird, that's an emu. And an emu is a grounded bird. It does not take flight, but you can see some similarities between the emu and this feathered dinosaur here. They have very similar necks, they've got the sharp beak, and even though they're different species, they look a lot alike. And so it's possible that through changes over time, through evolution, there's some type of related ancestor between these individuals. We're going to talk about that a whole lot more as we get into this unit. Before we really dive in, we need to know what's causing these changes. Okay? So if evolution is the changes over time, what is causing these changes? And there's something that we've already talked about in genetics when it came to changes in our DNA. If you recall, we had a brief portion of our genetics unit focused on mutations. And we talked about two types of mutations. We talked about DNA sequence mutations as well as chromosomal mutations. The DNA mutations, we're looking at changes in the letters of the DNA sequence. And some of these had really big effects on the individual. Some of them maybe didn't make a difference at all. Okay, it just depends on what letters got swapped out. As for chromosome mutations, those are a bit larger. It could be a portion of a chromosome's deleted. Maybe it was copied twice. Maybe it got flipped around or switched with another section, and can have a very large effect on the individual. Either way, these mutations are how we get changes from generation to generation. Okay, they aren't on purpose, they're accidents, essentially. But sometimes these accidents, while you normally would think they'd be negative, sometimes they can be good things. So let's talk about the negatives versus the positives here. Okay, and I mentioned this before. It's significant because they could have little to no effect. We know on the negative side, it can cause genetic disorders. But when it comes to evolution, we're going to focus on number 3. Mutations can cause variation or differences in species. Very important. So a harmful mutation is going to hinder the organism's ability to survive. In other words, this mutation is most likely going to lead to an early death. They typically don't remain in the population for very long, and they are not likely to be passed on to future offspring. So if a individual is born with a mutation that limits their ability to survive, it's not very likely they're going to make it to reproductive age. Okay, so for example, let's say you have a rabbit that has a mutation in its ligaments, which affects its ability to walk. that's a harmful mutation because it can't walk, and it's going to limit their ability to survive because if a predator were to come towards them, they won't be able to get away. So if a fox were to go after this rabbit, it's not likely to survive, and it's not likely to be able to reach an age for reproduction. So that's why harmful mutations don't last very long, typically, because the individual will die before they can pass it on to their offspring. Beneficial mutations, on the other hand, are something that we do want to pass on to our offspring. If you have a really good trait that helps you survive, you want to make sure that your children have that trait as well. If we have a beneficial mutation, we refer to it as an adaptation. Okay, so sometimes it's a compliment if somebody says, oh, they're good at adapting to their environment or adapting to situations, going with the flow kind of thing. An adaptation is a good thing to have, to be able to adapt to what's going on around you. And in nature, we have 3 categories of adaptations. You can have a structural adaptation, a physiological adaptation, or a behavioral adaptation. Now, these are not exclusive from each other. So you can have an adaptation that meets these 3 categories. So what's going to vary between them is the explanation of why. Right? So, for example, if we were supposed to be doing a CER and you state that something is physiological, it very well may be physiological as long as you provide me with the evidence. Okay? So let's get into what each of these mean. If we're talking about a structural adaptation, we're just talking about a specific feature or shape of the body. Okay? And I have a video that we're going to go over to kind of bring this to life for you. Right? So structural adaptation, we're just looking at the anatomy. When it comes to physiological, this is when a part of the body has a special function. Okay, so physiological is talking about function. And this is where your explanation is going to be very important. You can have a structural adaptation that has a physiological benefit. Okay, so you can have body features that are, I guess, mutations, we'll say, that are adaptations. But if you're explaining its function, it then becomes a physiological structure, or physiological adaptation. Excuse me, I misspoke. And then finally, behavioral is when you are essentially taking action or making decisions. There's plenty of behaviors that certain animals might do that maybe the others in their community wouldn't risk or wouldn't do, but they have found a way for it to be beneficial to them. And again, we're going to look at some examples of that. So I have a brief video for you. I am going to pause just a couple times to make some clarifications for you, but we're going to look at a couple different examples of adaptations in different species. The link to this is on your note document. It's also within the PowerPoint, and then here, obviously. But if you choose to look this up online on YouTube, it is the Adaptations video. The producer of this is TigTag, if you want to look it up, so that you're able to rewatch for any additional information that you want to review. Okay, so let's go ahead and look at a couple of examples of adaptations. In other words, what changes have been made to help an animal or even a plant survive?
This is the Gerenuk, a type of African antelope. It feeds on the spiky acacia plant. It has a special trick to reach the higher branches. Its hip joints are so flexible, its backbone can swivel until the gerenuk is able to stand completely upright on its back legs.
So here's a great example of how we've got all three adaptations in one example. So whichever adaptation I choose, it will be correct as long as I provide the explanation. Okay, so if I just talk about flexible ligaments in the hips, I've mentioned a structure. A structural adaptation is flexible ligaments. If I talk about a physiological, I would say that the gerenuk has hips that are able to swivel for standing. That's physiological, okay? The use of that structure to swivel. And finally, behavioral would be that they are choosing to stand upright so that they can reach those higher branches, and that's using the structure and physiology of their hips. Okay, so I just want you to be aware that when we are going over these adaptations, they're not going to be exclusive of one another. They're going to have some overlap, which is why your explanations are going to be very important. Let's continue. We've got quite a few more adaptations to talk about.
Once in position, the animal's slender head and incredibly bendy tongue allow it to nibble the tiny leaves between the thorny branches.
Narrow head, structural.
The hip joints, slender head, and bendy tongue all help the gerenuk survive in its environment. Features that help organisms survive are called adaptations. Polar bears have many adaptations that help them survive in the cold Arctic. They have a thick coat of fur made up of hollow hairs. Because they are hollow, these hairs not only keep the bears warm, but help them stay afloat.
So there's two adaptations right there. Structural being hollow hairs, because that is the structure of their coat, whereas physiologically, those hollow hairs are going to help keep them warm and help them float. So those are the functions or actions of that structure.
Their small ears help keep the water out and stop their eardrums freezing. And the long hairs between the pads on their feet help them grip the ice. Plants have adaptations too. The leaves of the Venus flytrap help it survive in soils which don't have many nutrients. The plant is able to get extra nutrients from the insects it catches and digests. Unfortunately, the ladybird does not have an adaptation that allows it to escape.
So that's clearly a behavior that most plants don't do. Most plants are not able to trap different insects that land there. So this plant has adapted a behavior to help it survive. And that's about it. Okay. So if you need to rewatch that video, I've provided you with the link. But all of that is getting us ready for our assignment for Module 1. You are going to be researching a species of your choice. And when I say you're researching a species, it needs to be a specific species. So, for example, say that you want to research the penguin. That's perfectly fine, except there's different types of penguins. Um, some live in tropical areas, whereas others are in the Antarctic. So I need you to specify which type of penguin you're researching. From there, once you know what species you're looking at, you're going to determine 3 of its adaptations and provide an argument for each one. So give me an example of a behavioral adaptation that species has, of a structural adaptation, and a physiological adaptation. They need to be 3 different ones, okay? And then finally, you're going to tell me, how does that specific adaptation help them survive in their specific environment? Again, specific. So if you're telling me the desert, which desert are you talking about? I want you to specifically tell me the Sahara Desert. Okay, I need to know what is the specific environment of your species and how is that individual able to survive there. Okay. Again, your assignment is due on the 20th, anytime. You're going to be doing this research, and the assignment is up on It's Learning. You'll just type directly into It's Learning, and once you submit that, it lets me know that you have handed in your document. Okay? If you have any questions or concerns, just reach out to me through email or Remind, and I'll get back to you as soon as I can, okay? All right. Thanks, guys.